They can be named by adding the prefix di, tri, etc. Phenols contain 3-hydroxyl group and one more. So if we name this type of compounds, we will say hydroxybenzene. That is, this phenol is also known as hydroxybenzene. Hydroxybenzene. So if there are 2 or 3 hydroxyl group, we call it as hydroxybenzenes. So in the first case, we can number it as 1, 2. So 1,2-dihydroxybenzene. Here 1, 3. 1,3-dihydroxybenzene and 1,4-dihydroxybenzene. Here 1, 2, 3 trihydroxybenzene. Here 1, 3, 5 trihydroxybenzene. But when we come to this compound, we can number it in either way, either from 2 ways, either from this phenol 1, 2, 3, 4, or either from this phenol 1, 2, 3, 4. When we number in the clockwise direction, we get the substituents number as 1, 3, 4. If it is in anti-clockwise direction, the number is like 1, 2, 4. So we have to choose the lowest sum rule. Here the lowest sum rule is the second one. It is anti-clockwise one. Here it is 8, here it is 7. So we have to number it as 1, 2, 3, 4. So the name is 1, 2, 4 trihydroxybenzene. നമ്മള് aliphatic compounds നെയിം ചെയ്യുന്നതിനേക്കാളും സിമ്പിൾ ആണ് അരോമാറ്റിക് കോമ്പൗണ്ട്സ് നമുക്ക് പേര് കൊടുക്കാം. ഫങ്ഷണൽ ഗ്രൂപ്പുള്ള അരോമാറ്റിക് കോമ്പൗണ്ട്സ് ഡയോപാക്നീൻ. അജയുടെ അച്ഛന് സുഖമില്ല അല്ലേ? മെസ്സേജ് അയച്ചിരുന്നു. കുറെ നാളായല്ലോ അല്ലേ അച്ഛന് സുഖമില്ലാണ്ട്. ക്ലാസ്സിലും കുറെ മിസ്സായിട്ടുണ്ടെന്ന് തോന്നുന്നു. So this is how we can name phenols. So phenols, the functional group is OH group and it is directly attached to the benzene nucleus. It is called phenol or hydroxybenzene. So if other substituents comes in the benzene ring, you will number in such a way that the hydroxyl group should get the minimum number and substituents also should occur minimum numbering. So first example 2,4-dichlorophenol, 2-nitrophenol, 4-aminophenol, 2-methyl-phenol. So if there are 2 or 3 hydroxyl group in the same ring, we will name it as hydroxybenzene. So this is 1,2-dihydroxybenzene. This is 1,3. This is 1,4-dihydroxybenzene. And if 3 hydroxyl groups are there, we can use the prefix tri. So this is 1,2,3 trihydroxybenzene, 1,3,4 trihydroxybenzene, and this is 1,2,4. So here in this case we have to apply the lowest sum rule. Understood? use the suffix nal, alkanal. So suppose the simplest aldehyde CHCHO, which contain one carbon atom. The aliphatic chain that contain one carbon aliphatic compound that contain one carbon atom, the root word is meth. So the functional group is aldehyde, so we use the suffix methanol. So this is methanol. This is two carbons, sorry, CH3CHO. This is three carbon. The chain contain three carbon. Here the carbon that the chain that contain the functional group is taken as the parent chain. Usually this aldehyde functional group usually seen at one end of the chain. So that chain is taken as the parent chain, and whatever be the if there are any other substituents present, methyl, what branch chain like methyl or ethyl, so we only give preference to the aldehyde only, the functional group only. If functional group is present, always give preference to functional group, any functional group. If it is alcohol, if it is ketone or aldehyde, anything. So functional group is given the first priority. So here 1, 2, 3. It is propanol. So there is no need of writing 1 here because it will come either this end or this end, only at the end of the carbon chain. So it is propanol. 1 is understood. The position is understood. And it would came in the second carbon. Only the aldehyde usually comes at the end of the chain. And this is 2 carbon. We can call it as ethanol. So depending after writing the root word, we can add the al for aldehydes. For in case of substituted aldehyde, we have to give preference to the functional group, and the CHO should get the least number, and it will appear always at the end of the parent chain. For example, CH3, CH, CH3, CHO. We can't number like this 1, 2, 3 in this way. This is wrong. So we have to include the functional group also along the in the parent chain. So 1, 2, 3. So the naming is the second carbon. There is a methyl group. So 2 methyl, and then you have to check how many numbers in the parent chain, number of carbon atoms. There are 3 carbon atoms, so we can name it as propanol. Similarly, CH3, CH2, CH3, CH2, CH, C2H5, CH2. So this will be the parent chain. So 1, 2, 3, 4, 5, 6. So 2 ethyl, 4 methyl hexanol. Suppose if phenyl group is present in the compound C6H5, CH2, CHO. In this case, the phenyl group is considered as a substituent. So this is ethanol, and in the ethanol, one hydrogen is replaced by a phenyl group. So this is 2-phenyl ethanol. This is 1 and this is 2. The substituent is in the second carbon atom. So 2-phenyl ethanol. So phenyl group is present. It is considered as the substituent. This is a case of aliphatic aldehydes. If we name aromatic aldehydes, we call it as benzaldehyde. Aromatic aldehydes means CHO is directly linked to the benzene ring, and this is called benzaldehyde. So the parent compound is benzaldehyde. So if there are other substituent, suppose CHO, OCH3, OH. Here also we have to use the lowest sum rule. So we have to number 1, 2, 3, 4. So here both aldehyde and hydroxyl group are present here. But the parent compound here is benzaldehyde. It is a derivative of benzaldehyde. So the aldehyde group should be given the first priority. So 1, 2, 3, 4. And don't number it from here. 1, 2, 3, 4. This is not a phenol, derivative of phenol. It's a derivative of benzaldehyde. So we can name it as 4-hydroxy 3-methoxy benzaldehyde. The substituents are numbered and named according to the alphabetic order. Okay. So this is 4-hydroxy 3-methoxy benzaldehyde. Next is ketones. Ketones we generally name as alkanones. Alkanone. So the lowest ketone CH3CO CH3. This is named as propanone. 1, 2, 3. There are 3 carbon atoms, so we can take it as propanone. 1, 2, 3, 4. CH3, CH3, CH3. This is 2-butanone. The numbering rule is same to all functional group. CH2, CO, CH3, Cl. This is 1, 2, 3. This is 1-chloro 2-propanone or 1-chloropropanone, because this carbonyl group will always present between 2 carbon atoms. So it doesn't get the first number, always starting from 2. So 1-chloropropanone. The position is understood. Next is CH3, CH3, CO, CH3, CH2, CH3. So this functional group should get the minimum number. So we have to number it from the left side. 1, 2, 3, 4, 5, 6. From here, we can number. If we number from the right side, 1, 2, 3, 4. This will get 4th position. So 3 is the least number. So we choose the numbering from left side. And there are 2 substituents, 2 methyl group. So we will name it as 2,4-dimethyl 3. How many carbon atoms? 6. Hexanone. So this is the naming method of aliphatic ketones. So in the case of aromatic ketones, aromatic ketones are usually phenyl substituted alkanones. They are named as, considered as phenyl substituted alkanones. Since keto group can't directly attach to the benzene. Keto group alone cannot directly be attached to the benzene. So it is always considered as phenyl substituted alkanones. So this is the first example, CH3. So this is phenyl ethanol. Phenyl ethanol. And this is CH2CO CH3. So here one hydrogen is replaced by phenyl group. So 1, 2, 3. 1 phenyl, 2 propanol. And this is another example. This is diphenyl methanol. Diphenyl methanol. Since it is contain one carbonate. So aromatic ketones are named according to the fact that they are phenyl substituted alkanones. And next is acids. Functional group acid. They are named as alkanoic acid. Alkanoic. In the case of aliphatic saturated compounds, alkanoic acid. The simplest acid that contains one carbon atom. Then its higher member CH3, CH2, 1, 2, 3, 4. 1, 2, 3, 4, 5. 4 times CH2COOH. This is a long chain carboxylic acid containing 4, 7, 1, 1, 2, 3, 4. How many carbon atoms? 1, 2, 2 plus 4, 6 plus 1, 7. Okay, 7 carbon atoms. So this is contain only one carbon, so we can write it as methanoic acid. Methanoic acid. And this contain 2 carbon atoms. We can name it as ethanoic acid. And this contains 7 carbon atoms, so heptanoic acid. So this is aliphatic saturated carboxylic acid. In case of unsaturated acid, we can name it as, if there is a double bond, we can name it as alkenoic acid. Alkenoic acid. And if there is a triple bond, alkynoic acid. For example, so here we have to mention the number of the double bond also. CH2 CHCOOH, then CH2 double bond CH2 COOH, then CH triple bond CH2 COOH. So the functional group should get the minimum number 1. So number like this from right to left. 1, 2, 3. Here also 1, 2, 3. 1, 2, 3, 4. So the first compound we will name it as 2. The double bond is between 2 and 3 carbon atoms. So we number the double bond as 2. 2 and how many carbon atoms? 3 carbon atoms. So 2 propenoic acid. Propenoic acid. Here 1, 1, 2, 3, 4. So double bond is between 3 and 4. So 3 butanoic acid. And here triple bond is there at the third position. So 3 butanoic acid. Is it clear? So in case of long chain carboxylic acids, the carboxyl group should get the lowest number. It should be given the first number. And if there is a phenyl ring present in the chain as a branch or substituent, it will considered as a substituent only. For example, C6H5CH2COOH in the acetic ethanoic acid derivative. One hydrogen is replaced by phenyl group. So it is named as phenyl ethanoic acid. Phenyl ethanoic acid. Then if it is a branched carboxylic acid, CH3COH. So 1, 2, 3, 4. 2-methyl butanoic acid. And if there is more than one substituent, if a methyl group is also more than one methyl group, we can name it as di, tri, etc. Then if a functional group other than acid group is there, for example, OH, CH2, CH2, COH. So this is also considered as a substituent OH group. So 1, 2, 3. So 3 hydroxy. At the third carbon, there is a hydroxy group. So 3 hydroxy propanoic acid. And here CH3, CH, NH2, COH. This is an amino acid. So it is 1, 2, 3. 2 amino propanoic acid. So the functional group carboxylic, if we are naming an acid derivative, we have to give the functional group the least number. Same way Cl, CH2, CH2, COOH. 1, 2, 3. 3-chloropropanoic acid. This is a case for aliphatic acids, aliphatic saturated or unsaturated acids. If we name aromatic acids, that is carboxyl group attached to a benzene ring, we call it as benzoic acid. And this is the benzoic acid. And its derivatives are named according to the parent compound. If OH group is present at the second position, we call it as 2-hydroxybenzoic acid. If an amino group is present at the fourth position, 4-aminobenzoic acid. Nitro group is the 4-nitrobenzoic acid. Like that, we have to name the aromatic acids. So there are, apart from this, there are some acid derivatives. First one is acid halides, acid chloride, acid bromide, acid halides. They are named as alkanoyl chloride. Alkanoyl chloride. The functional group is COX. That OH is replaced by a halogen in the carboxylic acid. This OH is replaced by
ഇത്തിരി സ്പീഡ് കുറയ്ക്കാവോ?
speed on.
എഴുതിപ്പോകാൻ പറ്റുന്നില്ല.
ഞാൻ നിങ്ങളുടെ കയ്യിൽ ടെക്സ്റ്റ് ഉണ്ടെന്ന് വിചാരിച്ചിട്ടാ ഞാൻ ഇങ്ങനെ പോകുന്നത്. ടെക്സ്റ്റ് നോക്കുന്നുണ്ടാവുമല്ലോ, അതുകൊണ്ടാണ് ഞാൻ നിങ്ങളോടൊന്ന് ചോദിക്കാതിരിക്കുന്നത്. അല്ലെങ്കിൽ നിങ്ങളെ കൊണ്ട് ഞാൻ ചെയ്യിപ്പിച്ചേനെ. ഓക്കെ ഓക്കെ, സോറി. ഇവിടെ വരെ മനസ്സിലായോ? Shall I repeat?
അരോമാറ്റിക് ആസിഡ്സ് വരെ കിട്ടി.
ഓക്കെ, അരോമാറ്റിക്. അപ്പം അത് കഴിഞ്ഞിട്ടുള്ളത് പറയാം. Next we have to name some acid derivatives. Derivatives എന്ന് പറഞ്ഞാൽ അറിയില്ലേ? Any compound that derive from the parent compound. ആസിഡിൽ നിന്ന് നമ്മൾ പ്രിപ്പയർ ചെയ്യുന്ന കോമ്പൗണ്ട്സ് നമ്മൾ ആസിഡ് ഡെറിവേറ്റീവ്സ് എന്ന് പറയും. അതിൽ ഫസ്റ്റ് വൺ ആസിഡ് ഹാലൈഡ്സ്. That means this is the carboxylic acid group COOH, and this OH is replaced by a halogen. The halogen is represented as X. This can be chlorine, bromine, iodine, any halogen. So this is the acid chloride functional group, C double bond OX, acid chloride. If it is Cl, we can say it as acid chloride. If it is Br, we can say it as acid bromide. So this is the functional group COX. And generally it is named as alkanoyl chloride. Alkanoyl chloride. If you do the example, you will understand. CH3COCl. This is the derivative of acetic chloro, derivative of acetic acid. In the acetic acid, CH3COOH, and the OH is replaced by a chlorine atom. So we can name it as, this contain two carbon atom. So the root word is eth. And this is acid chloride. We can name it as ethanoyl chloride. Ethanoyl chloride. But in the textbooks and all, we normally use the common word acetyl chloride. For all those compounds that we already named, that phenols, acids, aldehydes, they all have common names also. Some of the compounds have common names. Normally, in textbooks, in synthesis, or any type of description, they use the common name sometimes. So this is ethanoyl chloride, or we call it as acetyl chloride. That is a common name. You don't now. You just write down the IUPAC naming. Next is CH3CH2 COBr. This is 1, 2, 3. So it is 3 carbon atoms. So propanoyl bromide. Then another one, CH3 CHCl CH2 C double bond O Br. This is 1, 2, 3. Prop. The root word is prop, but the second carbon contain a substituent, chloro substituent. So we call it as, sorry, 1, 2, 3, 4. So the third carbon contain a substituent. So 3 chloro propanoyl bromide. Sorry, not propanoyl, butanoyl bromide. Similarly, if there is a phenyl group, it is used as substituent C6H5 COCl. This is benzoyl chloride. The parent compound is benzoyl chloride. Then another example, CH3 CH3 CHNH2 COCl. So 1, 2, 3, 4. So there is an amino group and a methyl group. So amino should be named first. So 2 amino, 3 methyl, butanoyl chloride. Another is an aromatic compound, COBr NH2. So 1, 2, 3, 4. 4 amino benzoyl bromide. C6H5 CH2 COCl. In this compound, this is considered as a substituent. So 2-phenyl ethanoyl chloride. Okay. So this is the first derivative, acid chloride, naming of acid chlorides. Next is acid anhydrides.